Alright, now that I've got a little time, I want to make a video on acids, bases, solutions, and organic compounds. I'm doing it in 3 different segments so they're not too long. This segment is the part on solutions. We could have covered solutions back in Unit 2 when we were talking about homogeneous mixtures, because that's what solutions are. Solutions are a homogeneous mixture of a solute and a solvent. The word homogeneous means the same thing it did back in Unit 2. It means that these substances mix evenly, so no matter where you look in the container, you always find the same amount. It means that the substances don't settle or separate, so given time they stay mixed. And in the case of solutions, you will not be able to see the particles anymore. Once they mix, it all looks very uniform. You can't see the separate substances. Solute and solvent are new words in this definition, words that we had not covered before. So we need to know what those mean. A solute is a substance that is dissolved. So in the case of sugar and water, the sugar is dissolved, so the sugar is the solute. In the case of salt water, salt is what's dissolved, so it is the solute. The solvent is what is dissolved in. So in the case of sugar water, water would be the solvent, because that's what the sugar is being dissolved in. Nail polish remover and nail polish. Nail polish is what's going to be dissolved, so that is the solute. It will be dissolved by the nail polish remover, so that will be our solvent. Solute and solvent are relatively easy to identify because in most cases there is some kind of dissolving taking place. The one that is dissolved is the solute, the one that's dissolved in is the solvent. If there is no true dissolving taking place, solute and solvent can be harder to identify. In those cases, look at amount. Whatever you have more of will be the solvent. Whatever you have less of will be the solute. Solubility is a term we have to know and understand. It came up back when we talked about physical properties in Unit 2. Solubility is a physical property. It describes making mixtures. Mixtures do not make new substances. So solubility was one of the physical properties we had on one of the practice sheets that we worked through. It can be interpreted 2 ways. Solubility can measure the amount of solute that is dissolved. When we talk about solubility, we could be talking about a limit. For example, the solubility of salt at 100 degrees Celsius is 40 grams of salt per 100 grams of water. It sets the limit. It tells us that we can't put any more than 40 grams of salt in 100 grams of water. The other way we can refer to solubility is in terms of whether or not something will dissolve. We can say a substance is soluble if it will dissolve in a given solvent. So for example, salt is soluble in water. In other words, salt will dissolve in water. If it's not soluble, it is insoluble. Insoluble is the opposite, so oil is insoluble in water. It does not dissolve in water. So again, another term we have to be familiar with. We do have to know that solubility is dependent on temperature. That's why when we look back here at this solubility, there is a temperature attached to it, 100 degrees Celsius. If it weren't 100 degrees Celsius, the solubility would be different. Solubility depends on temperature. And generally speaking, with the exception of gases, the higher the temperature, the higher the solubility. In this graph, we have the solubility of salt and sugar. It's in 100 grams of water. Looking at the sugar line, we can see that at the freezing point of water, 0 degrees Celsius, the solubility of sugar is a little over 175 grams per 100 grams of water. If we heat that water up to the boil, 100 degrees Celsius, the solubility jumps to almost 500 grams of sugar per 100 grams of water. We can dissolve over twice as much sugar in boiling water as we can in cold water. This is why when you make sweet tea and you add the sugar to it when it's hot, you get it really sweet. If though you're at a restaurant and they bring you a cold glass of tea and you're trying to add sugar to it, you can't get it as sweet as you like it. In that cold tea, you can dissolve much less sugar, so you can make it much less sweet. The line down here is for salt, and you'll see it doesn't change quite as dramatically. It does change. It is a slight increase from freezing to boiling. It affects each substance differently, but again, in general, higher temperature means higher solubility. Like I said, it does not apply to gases. Gases are the opposite. When you're talking about dissolving oxygen in water, you can put a lot more oxygen in cold water than you can hot water. So gases work in the opposite way. When you know these three terms, saturated, unsaturated, and supersaturated, saturated is a solution that's at the limit. It's dissolved all it can't hold any more. If you tried to add more solute to a saturated solution, it would just settle to the bottom. This is what happens to you when you try to add sugar to that unsweetened tea at the restaurant, the cold stuff. All the extra sugar just goes to the bottom once it's become saturated. This is what happens when you try to add sugar to Rice Krispie cereal. You get the sugar sludge on the bottom. That milk is already saturated. It's holding as much sugar as it can. So when you add more sugar to it, it just settles to the bottom. Unsaturated is below the limit. It can hold more solute. If the solution is unsaturated, you add more sugar to it. It will continue to dissolve that sugar until it becomes saturated. And think of these like towels. If you have a towel that is saturated, it will not soak up any more water. If you have a towel that is unsaturated, it will soak up water until it becomes saturated. The last one is supersaturated. Supersaturated means you're over the limit. The question is, how do you get over the limit? The answer, temperature. You saturate it when the solvent is hot, then you cool it down. The solubility drops, but it still holds all the solute that you put into it. So you end up with a solution that has more than the limit in it. This is that sweet tea that you make when it's still hot. Last thing for solutions is rate of solution, how fast the solute dissolves. And there are three factors that affect that: temperature, agitation or stirring, and the surface area of the solute. Increasing any of these three things will make the solute dissolve faster. So if you use a hot solvent as opposed to a cold one, it will dissolve faster. If you stir it, it will dissolve faster as opposed to just leaving it sit there by itself. The surface area of the solute, smaller pieces dissolve faster than bigger pieces. That's why when you have a Jawbreaker, if you crunch on it, it dissolves faster because you've made the pieces smaller. The old commercial, how many licks does it take to get to the center of a Tootsie Pop? You just sit there and suck on it. It's going to take a long time for it to dissolve. But if you crunch it, it dissolves faster because you make the pieces smaller. Again, that is solutions. Not much that we needed to add on that. If you have any questions, post them on the wall or ask me in class.